Assalamu alaikum viewers. Today I will discuss about Rankine cycle of power plant. It is most important for all over the industrial people. From this Rankine cycle I will try to explain if inlet steam pressure increase, what will be the effect on the steam turbine, and if steam pressure decrease, that time what will effect of the steam turbine. And I will also try to explain if steam temperature increase or decrease, what will be the effect on the steam turbine. This inlet steam temperature increase, that time steam flow increase or decrease, or turbine efficiency increase or decrease. I will explain about this in my videos. So maybe these videos will be long, that's why I will be make this video 2 or 3 part. So viewers, for better understanding you have to watch these videos. I hope it will be more helpful for all of the industrial people. So first time I will try to explain Rankine cycle of the power plant. Main component of the Rankine cycle required one feed pump, one boiler, one turbine and one condenser. By these 4 components make one Rankine cycle. So I will explain by a diagram. It will be more easier all of the viewers. So viewers, today's topic is Rankine cycle. Today's topic is Rankine cycle. I will discuss about this. For making this Rankine cycle required one feed pump. So you think this is the one types of feed pump. Required one feed pump and required one boiler. You think this is the boiler. Required one boiler and required one turbine. This is the turbine and required one condenser. In this condenser provided cooling water. You can provide cooling water on tube side, this side many tube. Okay, you think this is this side cooling water. These 4 components required for this Rankine cycle. Normally this Rankine cycle, this kinetic energy converted to mechanical energy, and from this mechanical energy getting electrical energy or electrical power. So this is happening on the Rankine cycle. So you think this is the 1 component and this is the number 2 component, and this is the number 3 and this is called number 4. So for Rankine cycle I will make one diagram. If I make one diagram it will be more easier. So this diagram I am making TS diagram. You think this is the TS diagram. This side temperature, TS means temperature, and this side S means entropy. So I am briefing shortly what is entropy. So entropy means randomness of molecule, or you can tell this disorderness of molecule. At absolute temperature entropy normally 0. If temperature increase, that time entropy increase, molecule increase. So entropy means randomness of molecule or disorderness of molecule. I am giving one easy example, it will be clear. You think for making tea need to provide heat on the water. After providing heat, this water side have molecule, this molecule randomness increase. After we are getting tea. So this is the one example about entropy. So you can think this is the TS diagram. By this TS diagram I will try to explain about the Rankine cycle. So on this TS diagram, this side this part is liquid part, and this side is you can think vapor side. Liquid zone, vapor zone. And this side you can think x equal 0. That means this dryness, liquid dryness, this side 0, and that side x equal 1. That means this side liquid zone, and in this liquid zone more moisture available on the liquid, fuller moisture. And this side vapor zone, when it will passes through the vapor zone, that time moisture will reduce, and this side you think no moisture free zone, this one. I hope it is also clear. If increase, this side moisture reduce, and if this side decrease, this side moisture will be increase. For understanding this dryness, I have given this example x equal 0, this side dryness 0, and this side dryness 1, means 100%. So this is the liquid zone, and this is the vapor zone. So what is pump? Pump is a mechanical device which is transported fluid one place to another place. All people knows about this. So this pump main function to the increase the pressure. So this is the pump discharge. If you provide fluid from this side, you can think this side you provide the liquid. After providing liquid, this side pressure will be increased. Okay, coming this side pressure will be increased. So because this side have some temperature, because this water have some temperature, you think this is temperature gap. So this is, you think this pump point is this point. This is the pump point. This side have some temperature. After transferring this liquid by this pump, this pressure will be increased. You think this pressure increase up to this point. After increasing this pressure, it will go to the where? So it will go to the, in the boiler are available economizer. So I am writing this one. You think this is economizer. It will go to the economizer. After passes this economizer, this liquid temperature will be increased. So increasing, where it will go? It will go to the top side. After passing this economizer, this temperature will be increased. You think this is going this side. This temperature will be increased. So after increasing this temperature, it will go to the boiler. After passes this economizer, it will go to the boiler. After going this boiler, this side we will add more heat. In this boiler, we are adding heat. More heat we are adding. Before this, I am completing this vapor dome. I am completing. So this is going like this. So this point in Rankine cycle, it is calling critical point. Critical point. You understand this one? This is critical point. But now I am coming this previous point. So you think this is the pump. By this pump, liquid transfer. After transferring, this pressure increase. This pressure increase coming this side. After it will go to the economizer, and economizer, you know about this economizer. Economizer, this liquid temperature increasing, this economizer temperature getting from this flue gas, this temperature getting, and counter contact, this liquid temperature increasing. So after increasing this liquid temperature, it will go to the boiler. On boiler side, we are adding heat, but this is liquid phase. After passing this liquid zone, this is liquid zone, and this is still now saturated steam. And up to this point, this is saturated steam. And from, you can think this is 1 and this is 2. From 1 point to 2 point, it is calling sensible heat, because 1 point to 2 point, this liquid phase not changes but temperature taking. After coming this point, when you provide more heat, temperature will not change. Temperature will not change. That time only phase change. If you think at atmospheric pressure, if you heat the water, that time what will happen? 100 degrees centigrade temperature, it will go to the saturated steam. That time if you provide more heat, that time this temperature will not increase. Some moment, small moment, this is a stay, phase change, liquid to vapor phase, it will be changed. Like this happening this side, when it has come that point, that time if you provide heat, that time temperature will not increase. That time temperature will not increase, and up to this point it is calling sensible heat. From 1 to this point, how much temperature it has taken, it is called sensible heat. I hope you understand what is the sensible heat. Sensible heat means for producing the saturated steam, how much temperature is required, it is calling the sensible heat. After coming this saturated point, this, if you provide temperature in boiler side, we are providing temperature, and boiler side this constant pressure, that's why it is calling isobaric process. This isobaric process, boiler side we are providing temperature. After providing temperature, this temperature will not increase. That time what will happen, it will go to the state. Why it will go to the state? Because this side temperature not increase and pressure is constant, but we are providing heat. This saturated steam taking heat, and slowly all are going to converted vapor. So this side you think up to this point 30% water converted to vapor, this side you think 50%, this side you think 75%, and this side you think the saturated steam fully converted to the vapor. This side you think up to this point this saturated steam fully converted to dry steam. That means all water converted to vapor or steam. This point all water converted to vapor or steam. I hope up to this point it is clear. But from this to this point temperature not increase, but they have taken heat. This heat is calling latent heat. How much heat is taken up to this point, this to that point, it is calling latent heat. But in this zone are available, there's some liquid and this side and some vapor. This zone, in middle zone, liquid and vapor. This liquid and vapor, and both are taking heat, and this heat is called latent heat. After taking latent heat, once time this temperature again will be increase. When this temperature again will be increase, after this temperature again will be increasing start. So from this to this point it is calling latent heat. And what is calling enthalpy? What is the enthalpy? What is the enthalpy? So enthalpy means sensible heat plus latent heat. Enthalpy means total heat. Sensible heat plus latent heat. Latent heat is called enthalpy. So enthalpy means sensible heat plus latent heat. That means enthalpy means total heat. Total heat is called enthalpy. So I hope enthalpy, entropy, sensible heat, this is sensible heat. Sensible heat about this is clear. What is happening on the Rankine cycle? So after coming this point, this side dry steam, and after coming this point, if you provided more heat, that time temperature will be increased. So we are providing more heat on the superheater. This side you think this is one type of superheater. By this superheater, this dry steam temperature again increase, and it is coming this point is called 3 point. So after passes this superheater, this steam will go to the where? This turbine. And this to this no changes, temperature, pressure no changes. That's why this and this point is same point. This is 2. This is 2, this is 3, and this is 4. Okay viewers, I am telling again, this is the pump. after passes this pump, this pressure increase. After increasing this pressure, it will go to the economizer. After going to the economizer, this temperature increase. After passes through the economizer, this temperature will be increase. This temperature increase coming this point. Or after coming this point, that time temperature is not increasing. That means liquid to vapor phase changing. Up to this point is calling sensible heat. From 2 to 3, this side, this flow has gone to the boiler, and on the boiler we are adding heat. After adding this heat, this side temperature not increasing. This temperature is taken, this wet steam, and this wet steam converted to dry steam. When it will come to the this point, this all steam will be to the dry. So wet steam to dry steam, this point is called to the latent heat. So after passes this latent heat time, this flow will go to the superheater. On this superheater also we are providing heat. By taking heat from the superheater, this steam will go to this point. After going to this point, this side totally dry steam. On this point there are not available moisture. That's why we are passing through this superheater. Because if we not passing through this superheater, what problem will be happen? That time when this steam will go to the turbine, when this steam expansion from the turbine, that time possible to some moisture on this steam. If moisture are available on the steam, that time turbine blade will be damaged or turbine will be damaged. For protecting the turbine, that's why this dry steam we are superheated to superheated steam, and superheated steam we are providing to the turbine. So this point will go to the turbines. After going to this turbine, this steam will expansion and it will come to this. After expansion, this will come to the condenser. So this will come to the straight to the condenser. So you think this is come to the condenser. You think this is the point 4. So this is coming to the condenser. After coming to the condenser, steam temperature reduce and pressure also reduce. And after coming to the condenser, this condenser provided cooling water. By this counter contact with cooling water, this temperature will be more reduced and this vapor phase will be changed, and after passes through this condenser, this vapor will be converted to the liquid, and after passes this condenser, it will again come to the pump suction. By this condenser side, latent heat release, and this point latent heat added. I hope understand. By this condenser, latent heat release. After releasing this heat, this vapor converted to liquid, and this side adding heat converted to steam. So from this point again it will go to the pump, and after it will go to the economizer, economizer to boiler, boiler to turbine, a turbine to condenser. So this Rankine cycle is working by this way. So from this it will come to the pump. So from this point it will come to the pump side. This point will come to the pump side. So Rankine sir, he has given like this example, this water, how it is cycling on this process. So I hope up to this it is clear. So viewers, in my next class I will explain if pressure increase on the system, what will effect on the turbine, and if temperature increase on the system, what will effect on the turbine. So in my next class I will explain about this point. So viewers, thanks for watching up to last moment. In my next class I will give more informative information to all.